Hello, everyone. Thank you, and welcome back to the innovation stage. We have an amazing presentation coming from Ben Cahoon, the CEO of Techcyte. I'm very excited to have him join us. He's doing some really interesting things. And please give Ben a very warm welcome to the virtual stage. Ben, if you would turn on your camera and audio and take it away with your presentation. I'll be here if you need anything.
Great, thank you. Let me share my screen here. Okay, great. Well, as said, I'm the CEO. I'm Ben Cahoon. I'm the CEO of Techcyte. And all of you, and obviously at this conference, we've seen lots of hype around AI and the things that it can potentially do in the future. And my goal today is to show you some real-world solutions that we've worked on that are in production, making an impact in human, veterinary, and environmental health. The first thing I'd like to start with is really the problem. As we've traveled the world to different labs and clinics around the world, it's very, very clear that there is an increasing shortage of labs, clinics, and pathologists to do these difficult jobs. And many labs are having a difficult time filling these positions. The work is tedious. You've got to be an expert. And the younger generation are going into things like genomics versus looking into a microscope. So that's really the problem that we're faced with. Let me give you a real world example to give you a feel for what how difficult this job is. So this is a human fecal sample. It's trichrome stained blue, and your goal as a parasitologist or a med tech in a lab is to look for parasites. And you're gonna have to look at these probably thousands of fields of view like this one every single day and look for Giardia tropes and amoebas, etc., that look very much like the shmoo around it. In this particular case, there's only one Giardia trope on the slide, and it happens to be right there in the middle. And you can tell that is very, very similar to many other objects on the page. So you've got to have a lot of expertise to know, what the internal features and what a Giardia trope looks like amongst, other parasites that can also be there. At Techcyte, what we do is we digitize this glass. The sample is done on a glass slide, which we digitize with the whole slide scanner. It goes up to our cloud platform where we analyze every single pixel of that gigapixel image, looking for the Giardia tropes, entamoebas, other parasites. And we present those back to the med tech or the parasitologist. They confirm it and move on to the next one. That traditional manual process on a microscope takes about 5 to 6 minutes, where with Techcyte, it's a 15 to 30 second job. So much better looking at a computer screen versus hunched over a microscope. So healthcare has not benefited in all cases from the digital revolution as much as some other industries. And they're dealing with a device that hasn't changed much in 400 years, the microscope. You've got to hunch over it, look at it, and be an expert to see what you see. Now, we agree with Dr. Lee that AI is going to change the world. And it's very, very clear to us that we can make that happen within microscopy. Most reference labs do about 300 tests with a microscope. So there's a lot of opportunity here to make a difference. So our mission at Techcyte is to automate and digitize diagnostics through the use of AI. And so bottom line, we want to eliminate that manual microscope and automate it and get to a nice big digital screen. We do this and we've tried to make the process simple for the lab. And it all starts off with sample prep. In many cases, these are liquid-based or smearable samples that are difficult to scan. So we start back at sample prep and see the types of things we can do to make it easier to scan, doing things like a monolayer so that the scanner can recognize that and scan it in. You basically take that slide that's prepped, put it on the scanner. In this case, this is a Grundium scanner. It only scans one slide at a time. It's small and compact, and it's great for a clinic or a low volume lab. You scan that slide, takes a few minutes to scan the slide. It creates a gigapixel image that's then sent up to the cloud where we analyze it using AI and then report out on that. Generally, the techs confirm what we've presented to them, and then you report out through a lab information system, or we need to just get the data out to their existing reporting system. The bottom line of that whole process is we increase the accuracy and we lower the cost. Now, there's a lot of other soft benefits. It's just a better job and working environment for the tech. But really, when it comes down to it, in terms of ROI, increasing accuracy, which affects patient health, and lowering costs are the things that people care about. Now, I mentioned those slide scanners. This is the Grundium AUKUS scanner, and they're out of Finland, and they are ex-Nokia and Microsoft engineers that have created this wonderful small scanner that goes in clinics for low volume applications. We've worked very, very closely with them to streamline the experience for the clinics and the labs. We also have worked with companies like Hamamatsu. Hamamatsu has this S360 where you can load up 360 slides at a time. So this is for high volume, high reliability labs. We work with all types of scanners, but we've really optimized the workflow with Grundium Hamamatsu to make it really simple. The bottom line, the result is we can take a regular human and make them a superhero by putting on the suit of AI, and the results are pretty impressive. Whether it's increased accuracy or decreasing the time that it takes to read a slide with pap smears, fecal, mold, blood, etc. The results are impressive, and they make a big difference in humans' lives. Now, a 5.7 increase improvement in pap may not seem big, but that could affect 1.2 million women a year that may have received a wrong diagnosis. So this does have the ability to make an impact on human health. Now, we start off doing this with image data from those gigapixel images that are annotated by experts and then trained into a deep learning object detection network. And we do that multiple times a day. Each algorithm starts from scratch and really doesn't know anything about previous algorithms. Once it goes to the object detection network, and you create then at the end of the day an algorithm or a classifier, which then when you put in a new gigapixel images, it finds the objects that you care about. We optimize hyperparameters and have developed a lot of tools to use precision recall curves, confusion matrices, custom model scores to help select the best models. That's really the core value, of the solution, of the platform that we built. Then we've got workflow around that makes it easy. At the end of the day, we like cells and liquid-based prep, and this is a tool that is specifically for that purpose. This is a 3D rendering tool that we call the cluster view. Each one of those dots and different colors represents a different class and a different image in our training set. And this is how the AI has clustered those different classifications. So this 3D visualization helps us then select the areas that may not be, if there's colors overlapping, we can select each of those images and change them. If it was a mistake or something just happened to the data set, we can clean that up, and it goes from taking months to clean it up to literally days. At the end result, you get that classifier, the algorithm, and you can see this isn't human fecal anymore. This is a companion animal fecal slide, probably a dog slide, and you can see that the object detection network boxed and classified each one of these different the different parasites it was looking for, and it does a really good job at that. In this particular case, it's as good as an expert in a university. And it's way better than just regular clinicians at a veterinary clinic. And you can see that it did not box the other shmoo. So it boxed only things we cared about and got them correct and left everything else alone. We did that algorithm for Zoetis. Now, Zoetis is the leader in the vet industry, and they secured a worldwide exclusive license to our technology, and they branded it VetScan Imagist. So this technology is primarily used in about 70,000 veterinary clinics around the world, but it also can be used in their reference labs. Now, VetScan Imagist uses that Grundium scanner, that small little scanner, because in a veterinary clinic, there's very limited space, and turnaround time is very crucial. So it happens very, very quickly. And as I mentioned, the results got so good with this algorithm that it's better than the clinic's expertise and mimics or is as good as an expert at a university. Now, that platform with the small scanner and the AI and the workflow, we can add on many more tests such as blood, fine needle aspirates, urine, etc., that will work for veterinary clinics and get fast results back to patients. We've also done this on the human side. So with ARUP is a reference lab, a well respected reference lab in the United States. And we did that trichrome fecal test with them. It's been in production since August 2019. And these are their words. It's an unmitigated success. It's really helped them find, like I mentioned before, increase their accuracy and lower their costs. And the techs that are using this day to day love it because they're not hunched over a microscope. They're looking at a nice big computer screen, and the AI basically finds the parasites for them and they just confirm them. That turned into a JCM article in the American Society for Microbiology. That's a peer-reviewed journal. It's very prestigious, and it validated our sensitivity and specificity. And is much more. They also did a limit of detection study that found that it was 5 times more sensitive than doing the manual method. So it's fun to see this in real life and making an impact in human health. We also have an environmental test that's called SporeCyte. With reading spore traces, in traditional method, you only read about 20 to 30% of the slide or the trace. And that results in errors because the distribution could be different across each slide. We analyze the whole trace and recognize 150 types of spores, pollen, and particulates. And that results in, again, more accurate, consistent results for homeowners and building owners as they try to find out if they have a mold problem or a particular problem in their home or building. We have many other algorithms in addition to fecal and mold. So we've done bacteriology, hematology, which is blood, and also pap smears. And we'll be doing a whole bunch of other algorithms as listed on this screen. You can see that between human, animal, and environmental health, there are lots of different tests that we can go and do. And we are excited to make a significant difference across all of these industries. In most cases, we're automating existing tests, but we are working on tests that will be able to even do things that humans don't do on the microscope today by analyzing features in the model that humans have a difficult time recognizing. So that's Techcyte. I hope I've sort of boiled down the hype of AI to real world solutions and how we accomplish those solutions. And if you have any other questions, feel free to reach out, or if you'd like to partner on a project in microscopy or any one of these industries, we'd love to work with you. I appreciate your time today, and have a great day. Thank you.
Big virtual round of applause for Ben. Thank you, Ben. And go out and, if you're watching this, network with people and get excited about AI innovation. Thank you so much. Bye-bye.